quiero dar la palabra a mi compañera Ria Pierre, que va a estar introduciendo a Michael Brennan de NOAA para hacer una introducción y una explicación de lo que va a ser la temporada de huracanes de una manera mucho más técnica y mucho más científica. Adelante, Ria. Please, Ria, go on. Welcome to the conference.
Hi, good morning and welcome everyone to 2021 Hurricane Forecasting, brought to us by the National Oceanic and Atmospheric Administration of the U.S. Department of Commerce, the National Hurricane Center in Miami. We have with us today the very distinguished Dr. Michael Brennan, who will take us through this morning's sessions. Michael Brennan, PhD, is the branch chief of the Hurricane Specialist Unit at NOAA's Hurricane Center in Miami. The Hurricane Specialist Unit issues tropical cyclone forecasts and warnings for the Atlantic and Eastern North Pacific hurricane basins. Dr. Brennan served as the Senior Hurricane Specialist at NHC from 2008 to 2018, a position where operational duties include the issuance of track, intensity, and wind radii forecasts and associated watches and warnings for tropical cyclones in the Atlantic and Eastern North Pacific oceans. Along with his current position, he also conducts training on a variety of topics related to tropical cyclones, as well as National Hurricane Center products for forecasts, including forecast uncertainty and messaging. Dr. Brennan served as a presenter for numerous scientific meetings, including conferences of the American Meteorological Society, the American Geophysical Union, and the National Weather Association. Dr. Brennan serves as a reviewer for several scientific journals and is currently an associate editor for the AMS journal, Weather and Forecasting. So without further ado, I'd like to turn over the floor to Dr. Brennan.
Thank you. Good morning, Ria. Good morning, everyone. Thank you for the opportunity to speak with you all today as we are already into the early parts of the 2021 hurricane season. And I want to present some information today about hurricane threats and hazards and about the products that we issue from the National Hurricane Center, which is also known as RSMC Miami. So I'm going to try and share my screen here and present to you the presentation I have today. So what I'm going to provide is an overview of a brief understanding of National Hurricane Center products and sort of our responsibility. Here's a picture of our facility here in Miami, where we're located. We've been in this facility for about 25 years now, actually. We're located with the local weather forecast office. It's part of the National Weather Service here in Miami that covers, has responsibility for South Florida as well. But our main, our mission statement that you see here is to save lives, protect, mitigate property loss, and improve economic efficiency by issuing the best watches, warnings, and forecasts of hazardous tropical weather, and by increasing understanding of these hazards. And one of the biggest threats in terms of hazardous tropical weather are tropical cyclones, and that's what I'll focus on here today. So globally, the National Hurricane Center is one of 7 regional specialized meteorological centers, or RSMCs, that produce and coordinate tropical cyclone forecasts across the various ocean basins of the world. So we are RSMC Miami, that you see here, and our area of responsibility is shown here for the North Atlantic and Eastern North Pacific. You can see the other RSMCs around the world that stretch across the Pacific on Honolulu and Tokyo, Nandi, Fiji in the South Pacific, Australia, La Reunion in the South Indian Ocean, and New Delhi in the North Indian Ocean. So combined together, all of these agencies work together to protect lives and property for all areas that are affected by tropical cyclones around the world. We do a lot of that through international collaboration. While we're making the forecast for the storm, its track, its intensity, its size, and the overall large-scale hazards of storm surge and rainfall and wind, we coordinate with all the countries in our area of responsibility, including those in WMO Region 4, that include all the countries in the Caribbean area, Central America, as well as Mexico, Canada, and Bermuda, as well as countries even outside of RA4, but still within the Atlantic Basin, such as the Azores, or countries in Northwest Europe. So a large part of our mission is communicating the forecast information to these countries that then issue their own watches and warnings for their own local populations based on the hazards that we're expecting to occur in their area of responsibility. Here's another look at NHC's area of hurricane forecast responsibility. So on the Atlantic side, we have responsibility for the entire North Atlantic, including the Caribbean Sea and the Gulf of Mexico. We also have responsibility for the Eastern North Pacific east of 140 degrees west, which is a little more than halfway from the west coast of North America out to the Hawaiian Islands. But so these are the areas that we have primary responsibility for, issuing forecasts and watches and warnings and coordinating those watches and warnings with our international partners. So focusing in specifically on the Caribbean, our coordination and interaction with them is really based on several principles. First is an open exchange of meteorological data. We're all trying to exchange data, provide data to each other so that we can protect lives and property. So we're providing forecast information and the countries in the Caribbean and elsewhere providing us with observational data, radar data that then help our analyses and forecast of the storm itself. And we provide forecast and guidance on watches and warnings to 30 different member nations of the World Meteorological Organization. And the coordination in the Atlantic and the Eastern North Pacific basins is governed by a regional hurricane operations plan. And, I'm really proud to say that I think it's the best plan of all the regions across the world. We have a really good relationship with our WMO partners within RA4 and elsewhere within our area of responsibility. And I think it's really the gold standard for how the relationship between the RSMC and the regional member nations should work throughout the globe. We have an annual Region 4 Hurricane Committee meeting, and that's where this plan is updated. We've unfortunately, due to COVID, had to have the meeting sort of virtually the last 2 years, but usually the meeting is held in person. And the NHC director, which is Ken Graham, serves as the chairperson of the RA4 Hurricane Committee. And so all the countries come together in this Hurricane Committee meeting each year and agree on the plan and agree on how we're all going to coordinate and exchange data with each other. Now we'll talk a little bit about tropical cyclone climatology in the Atlantic Basin. This is the track of all the major hurricanes in the Atlantic Basin going back to 1851. So you can see that the hurricane portions of the track is shown in red, or tropical storm or hurricane portions of the track shown in red. The major hurricane portion of the track, so categories 3, 4, or 5 on the Saffir-Simpson hurricane wind scale, are shown in yellow. So you can see that the Caribbean region and much of the Atlantic Basin, especially west of about 60 degrees west, is vulnerable to the effects of major hurricanes and certainly tropical storms and hurricanes in general. So they can affect and do affect just about every country in the Caribbean region. We'll talk a little bit about the annual climatology of Atlantic hurricanes. Now that we've just finished the decade of the 2010s, we've now moved on and we've computed new 30-year averages for average Atlantic hurricane season activity that have become effective this year. So the new averages are that cover the period from 1991 to 2020, include 14 named storms, 7 hurricanes, and 3 major hurricanes. So compared to the previous averages, which were based on the 1981 to 2010 time period, that was 12 named storms, 6 hurricanes, and 3 major hurricanes. So you can see that our level of sort of average activity has gone up by about 2 named storms and about 1 hurricane for an average year. So some of this is due in part to just improved ability to detect weaker and shorter lived tropical storms, especially. But we are, given the 30-year averaging period, we are losing the 1980s, which were a relatively quiet decade in terms of just overall activity in the basin, and adding in the 2010 to 2019 or 2020 era, which has been quite busy, especially since 2016. So this is, again, just sort of the typical level of activity that we could expect in any given year in the Atlantic Basin. Here's how the hurricane season plays out in terms of activity as we go through the season. So what you're looking at here is what we like to call a campfire diagram. It sort of looks like a campfire display. But what you're looking at here as you go across are the dates as we go actually from before the hurricane season starts in early May all the way through the end of the calendar year in late December. And what you see here in red is the number of active tropical storms and hurricanes on any given day in the year. and the yellow shows the active number of hurricanes on that given day within a given within the year. So what you can see is that the peak of hurricane season, defined by the date that you're most likely to have an active tropical storm or hurricane going on in the Atlantic Basin, is September 10th. So you see about 9 out of 10 years, you're going to have a storm active on that date in the basin. So 90 storms in about a 100-year time period. But you can see the sort of progression of the seasonal activity starts off obviously very low in May before the official start of hurricane season. And then there's sort of this steady low level of activity as we go through June and July. And then as we get to late July and August, the activity levels ramp up very quickly as the Cape Verde season, where we can get those longer track Atlantic hurricanes to form. And then we really hit the peak of the season as we go from mid-August into early September. And then the season tends to lag on. We see a drop-off in activity as we get into early October, and then sort of a secondary peak in late October as we get a shift in focus towards development more in the Caribbean region as fronts begin to work their way down into the Gulf of Mexico and the Caribbean and serve as an additional focus for storm development. And then we typically see that activity tail off rather quickly as we get into early and mid-November, and then back down to very low levels of background activity as we end the hurricane season and go into December. Here's just a climatology in terms of geography and where we see storms typically form and move as we go through the season. So right now we're in June. We typically see about 1 storm form in June about every other year on average. Most storms in June tend to form over the northwestern Caribbean Sea or the Gulf of Mexico. Those are areas where the water is warm enough to support storm formation even very early in the season. These storms tend to form from decaying frontal boundaries or other types of continental or mid-latitude features that not really forming out of the deep tropics yet, or those sort of tropical wave type scenarios as we are in June. A challenge with the storms in June is that they tend to form very close to land, and they tend to affect land in a very short period of time. So we don't always have a lot of lead time before those systems begin to affect people, maybe just even a day or two, or even less in some cases. As we move into July, we typically see about 1 named storm every year in the month of July. The areas of likely development start to expand out to the east now and include the southwestern Atlantic, the Gulf of Mexico, and pretty much the entire Caribbean Sea. We start to see more prevalent tropical waves as we get into July, and more potential development for those waves as they come across the Atlantic and move into the Caribbean. So we tend to see sort of this opening of a window as we go eastward as the season progresses. Then as we get into August, the activity typically increases. We see 2 to 3 named storms form in the month of August, and the Cape Verde or tropical wave peak of hurricane season begins. And we can see development out here in what we call the main development region in the deep tropical Atlantic. So waves can begin to form as soon as they move off the coast of Africa and track either westward toward the Caribbean or north of the Caribbean and towards the North American continent, and either move toward the Gulf of Mexico or the Bahamas or Florida, or recurve along the United States East Coast. But you can see that much more of the Atlantic Basin is sort of open for business in terms of the ability of, or the location where we can expect storms to form that time of year. And then September, as we move on, is the typical peak of the season. Storms can form just about anywhere in the basin. Waters are warm, shear is typically low. We can have development all the way from the deep tropics into the subtropics and even the mid-latitudes. And these very long track, sort of classical Cape Verde storms that form in the eastern part of the basin and move all the way across the basin are most likely in this month. Then as we get to October, things sort of quickly change. The Cape Verde season really ends. The waters are still warm, but the vertical wind shear, or the change in wind speed and direction with height, really begins to increase and sort of shuts off development over the eastern Atlantic. The areas of development really shift westward back towards the Caribbean Sea, the Gulf of Mexico, and the western Atlantic. And this is sort of that secondary peak of the season that we saw in the campfire diagram, where you see that sort of plateauing of activity or even a slight uptick in activity as we get into mid-October. The typical tracks for these systems begin to move northward and northwestward out of the tropics and into the mid-latitudes. And then as we get into November, the season usually slows down pretty dramatically, although as we saw last year with the devastating impacts of Eta and Iota in Central America, that's not always the case. But we typically see about a storm every other year in November, and usually the general area for formation at that late in the season is in the central and western Caribbean. We can also see subtropical development over the northern and central Atlantic at that time of year. So, and that's sort of, again, you can see that window opening as we get towards September, and then it closes back toward the west late in the season as the conditions become less favorable for formation across the basin. Now I'll talk a little bit about progress in forecasting, track, and intensity of tropical storms and hurricanes. What you're looking at here on the left is NHC's average track forecast errors by decade for Atlantic tropical storms and hurricanes. You can see the pink, starting in the purple here in the 1960s, then the 1970s and 80s. There was very little progress, or very just slow progress, in improving track forecasts. Then we saw a big reduction in track forecast error as we moved into the 1990s. And then that reduction in error has really increased, or has continued, I should say, through the first 2 decades of this century. And we've seen this sort of very steady, significant improvement in track forecast error. You can compare these 72-hour or 3-day track forecast error over the last 10 years was about 100 miles. And you can compare that to 30 or 40 years ago, it was 300 to 400 miles. So we've made tremendous progress here that's really been driven by improvements in global weather model forecasting that really does a good job forecasting the large scale features in the atmosphere that govern the motion of tropical storms and hurricanes. So we've been the beneficiaries of those really significant improvements in numerical modeling that have helped improve hurricane forecast. What you're looking at on the right is a similar plot, but for hurricane intensity. How strong are storms going to be? And you can see that it's a very different picture. You can see that for the first 4 decades shown in this chart, basically the 1970s up through the first decade of the 2000s, there was very small or very incremental improvements in changing intensity forecast error. But in the last 10 years, we've seen a pretty significant reduction in error by as much as 30 or 40%, especially out beyond about the first day and a half of the forecast. You can compare our average intensity error at day 3 now is about 14 knots or 13 or 14 knots compared to probably 17 or 18 knots about 10 years ago. So this has really been driven by improvements in hurricane-specific modeling. These regional models that we run, like the HWRF, that are focused on specifically improving hurricane intensity prediction. And we've begun to see some benefits from that. We're also seeing the benefits of better use of aircraft data in terms of radar data from dropsondes, data from the aircraft itself, getting into the models and helping improve those intensity forecasts. So we're proud to say that finally, we are starting to see some progress in intensity forecasting. We're not where we want to be or where we need to be, but it is good to see some movement in the right direction. So I'll talk now about the products that the National Hurricane Center produces. And we really provide the big picture that is following the storm throughout its entire life cycle, that really complements and guides the products that are issued by the meteorological services of each country within our area of responsibility. So we're following the storm through its entire lifespan, from before it forms, through its development and intensification phases, to its decay, to all the way to its dissipation. And we're really focused on the big picture. Where is the storm going over the next several days? How strong is it going to be? How big is the wind field going to be? What are the large scale hazards going to be in terms of the wind, the storm surge, the rainfall? And then the local meteorological services in each country really take that information and translate it down to what the local impacts are going to be in their given area of responsibility, and take care of issuing the watches and warnings for their jurisdictions. So as we go through time, this chart sort of shows the progression from several days away from a potential impact all the way through when the impacts start, and shows you what products are available and sort of what the messaging strategy is. Because early on, there's very large uncertainty. If you're more than 5 days away from a potential impact at a given location, there may not even be a tropical cyclone yet. We may only have the tropical weather outlook, which I'll talk about in a minute, which talks about the potential for tropical depression or tropical storm formation out through the next 5 days. Or we may have an active system, but our forecast only goes out 5 days, because beyond that time frame, there's really too much uncertainty to be very specific about where the storm might go or what the potential impacts might be at a given location. When we get to within the 3 to 5 day time frame, we have our NHC forecast that goes out to 5 days. We have some products that talk about the threat for seeing tropical storm or hurricane force winds at a given location, the wind speed probabilities. We have our forecast discussion. We can start talking about potential impacts and start to talk about sort of larger geographic areas that might be affected by the storm, talk about how the threat is increasing or decreasing at a given location. When we get out to about 2 to 3 days out, that's when the typical time frame for issuing tropical storm or hurricane watches. And now we're closer in, we can start to hone in on the area that's going to see those potentially more significant impacts. We can start providing, and we get inside the warning time frame. Now we're talking about conditions expected to occur within a given location within 36 hours or so. We have more products, more specific products about storm surge that we're expanding out through the Caribbean. There may be more products coming from a local meteorological office that again can get down to that sort of finer scale detail for the area being affected. As we get into that sort of impacts time frame within the last day or so before the storm arrives. So here's, we'll start talking about sort of the top of that pyramid, the tropical weather outlook, which is issued to talk about what's going on in the tropics. What are the potential systems that we have to watch for formation over the next several days? We issue the outlook at 2 a.m. and 8 a.m. Eastern Daylight Time, as well as 2 p.m. and 8 p.m. Eastern Daylight Time, starting May 15th and continuing all the way through November 30th. We can also issue what we call a special tropical weather outlook that can be issued at any time for significant or unexpected changes or outside the time period from May 15th to November 30th when we're issuing the outlook every 6 hours. So here's what that product looks like. It's a text product. We talk about each system or disturbance we're talking about has a sort of its own paragraph. We talk about where the system's located, if it exists, or what it's the factors that are going to affect its potential for development over the next several days. Where is the system going to be moving? Where is it located now? What should people be on the lookout for? And then we provide information about for the fact that there's an aircraft planning to fly into the disturbance. Interest in the Yucatan Peninsula should monitor the progress of the system. And then we provide a chance of formation of this system in the next 48 hours and also through the next 5 days. So there can be, sometimes there's nothing in the outlook. Other times there may be 4 or 5 systems we're talking about in the outlook. And it just varies depending on the level of activity. And we also have a graphical version of the TWO that's been around now for many years. It's sort of a nice briefing snapshot that shows the current location of the disturbances that are mentioned in the outlook are shown by these X's that are color-coded by the chance of development in the next 48 hours. So this yellow X here represents this tropical wave coming off the west coast of Africa that has a low chance of formation over the next 48 hours, 20%. Then we also have a red X here in the tropical Atlantic just to the west of the Cabo Verde Islands that shows that this system has a high chance of development in the next 48 hours, an 80% chance as you see on the graphic. This graphic also shows other active systems that we're writing advisories on. So here's Hurricane Florence, here's Tropical Depression Gordon that's moved inland. So it's sort of a nice snapshot of current and ongoing activity overlaid with satellite imagery. And we also have a 5-day graphical outlook that shows the 5-day formation potential and shows these hatched areas that are drawn to show where we expect formation could occur. So if the system exists initially, you'll see an X on here, but sometimes at 5 days out, we actually have a system that doesn't even formed yet. So you might just see one of these shaded areas out by its own. But the color of the shaded area and the X is based on the system's formation potential during the next 5 days. So you can see that while the system coming off the west coast of Africa at 2 days had a low chance of formation, 20%, for 5 days, it has a 40% chance or medium chance of development. Whereas the system here farther to the west has a high chance of development during the 5-day period as well. And you can see the potential formation area for both of these systems. Once we have an advisory, once we actually have a system, we start issuing what we call advisories on it. And we issue advisories for tropical cyclones, which include tropical depressions, tropical storms, and hurricanes. But we also now have the ability to issue advisories on systems that used to be tropical cyclones, like a post-tropical cyclone that remains a threat to land. And also, especially importantly for the Caribbean region, systems that are not yet tropical cyclones, but could bring the threat of tropical storm force winds to land within 48 hours within that watch warning time frame. And we call these systems potential tropical cyclones. And this concept was introduced in 2017. It allows us to be able to issue our entire suite of forecasts and get watches and warnings out for a system that could already be bringing tropical storm conditions or is expected to bring tropical storm conditions to land areas within the watch warning time frame. So how does our advisory timeline work? Well, we issue a full advisory package every 6 hours at 5 and 11 a.m. and p.m. Eastern Daylight Time or Atlantic Standard Time. And the NHC advisory package, when we talk about the full package, includes a full 5-day forecast, includes products like the public advisory, the forecast discussion, the wind speed probabilities, the cone graphic, possible storm surge products. And then when watches and warnings are in effect, we issue a public advisory, then 3 hours later, what we call an intermediate advisory. And that updates the current information about the storm. Where is it located? How strong is it? We can also make changes to international watches and warnings on intermediate advisories. And then 3 hours later, we issue the next full advisory package at 11 a.m. and then followed by an intermediate advisory at 2, a full advisory package at 5. So we have this sort of 3-hour cadence of information that's coming out about a storm. So you get a full forecast every 6 hours and an update every 3 hours in between those full advisory packages. Here's some of the key text products that are part of our advisory package. We have the public advisory, we have the tropical cyclone discussion, we have the forecast advisory. Those are sort of the three most viewed ones and sort of contain the most important information. And we'll talk a little bit more about those products here as we go forward. So when people are wanting to know, how strong is the storm? What are the hazards? What kind of watches and warnings are in effect? That's when you're going to look at the public advisory. So the public advisory, plain text product. It's written in very plain language. It was originally intended as sort of a rip and read, like you would rip it off the teletype or printer and then read the information out to users on the radio, for example. So it's sort of a little bit of a historical flavor to it. But it's really sort of the product that contains the most general sort of public information about the storm, about the location of the storm. Where is it now? We're going to give this location relative to its latitude and longitude of the center, its location relative to one or two geographic reference points. How strong is the storm? What are its maximum sustained winds? How is the storm moving? What's its minimum pressure? What are the watches and warnings in effect for the storm? That's all going to be contained up here at the very top of this public advisory. So to get that sort of most important information out there very quickly. Then we have a discussion and outlook section that talks about the forecast track of the storm over the next 3 days. What's the motion? Where is the storm going to be moving? Where's the storm going to be in 2 or 3 days? Which areas are going to be potentially affected by the system? And we have a paragraph that talks about the intensity. What's the current intensity of the storm? Is it expected to strengthen or weaken over the next 3 days? Then we talk about the structure, the pressure of the storm, and then we move on to the hazards. How much storm surge inundation is expected, or what's the storm surge forecast? What's the rainfall? How much flooding? What areas are we concerned about for flooding? When are tropical storm force winds expected to arrive in a given location? So all that information is going to be contained in that public advisory. We also have the ability to issue what we call key messages, these sort of very high level 3 or 4 most important talking points we want to get across about a system. We also know people are interested in the confidence in the forecast. What's the reasoning of the forecaster? What information are they looking at? Do they think the confidence in the forecast is higher or lower than average? You can find that information in the forecast discussion or the tropical cyclone discussion. So this really talks about a lot of different information in here. This is sort of your chance to peer inside the thinking process or the thought process of the forecaster. What's their forecast reasoning? What are the observational data that's been important to establishing the current intensity or location of the storm? We're going to talk about the model guidance, how the model guidance is changing, how the NHC forecast is changing. What are the uncertainties in the forecast? For example, here we talk about there's been no change in the guidance. It's still quite clustered and brings the core of Irma very near Southeast Florida in about 3 days. We talk about the intensity forecast as well. So this is really the place where the forecaster can express the most information about the confidence in the forecast and sort of provide that information to users. We can also, this is where we also provide the key messages where we talk about forecast confidence. We highlight the threats. We really try to make these very hazard focused, talking about the threat from storm surge, wind, rainfall, and flooding. What are the areas that are most at risk from these hazards? And you can see what we did here for Irma. We have a key message talking about the potentially catastrophic impacts across portions of Hispaniola, the Bahamas, Turks and Caicos. Irma expected to affect Cuba as we go into Friday and Saturday, and then the threats for impacts from Irma in portions of Florida. So this is really an important piece of information we try to get out. It's found in the tropical cyclone discussion. We also create a graphic with the key messages that we post on the NHC website, and we also share on social media. We also have in the bottom of the forecast discussion a table of the track and the intensity forecast information all the way out through 5 days. So it's a very quick place to see the forecast information in terms of the track and intensity. Now, we can talk a little bit about the cone graphic. Everybody's pretty familiar with this. It's been around for a long time. The cone graphic is a great sort of high-level briefing tool, but it only contains information about track forecast uncertainty. It doesn't tell you anything about the impacts that the storm is going to potentially bring or could bring to a given geographic area. Impacts can also occur well outside the area that's enclosed by the cone, because the center of the cone is expected to move outside, the center of the storm, is expected to move outside of the cone about 1/3 of the time. And the cone doesn't really change size. It's the same for every storm all year long. It doesn't care if the storm is big or small, or the forecast uncertainty is larger or smaller than normal. So you can see early on, even in this example here, the wind field of the storm here extends well outside of the cone, even within the watch warning time frame. So the cone itself is not very useful for hazard-based decision-making. It's sort of more just a very high-level briefing tool. Okay, where is the forecast track of the storm going to go over the next several days? What are some areas that could potentially be affected in a very broad sense? The other challenge is that as our track forecast areas have gotten smaller, remember we showed how they've really continued to shrink over the last 10 or 20 years. Because of that, the cone has gotten smaller, because the cone is drawn so that the center of the storm should remain inside the cone about 2/3 of the time. So as our track forecast areas get smaller, the cone itself gets smaller. And you can see that in this graphic here, whereas you look back to what the cone size was in 2005, shown here in purple, compared to what the cone size is now, shown in red, you can see the cone has really decreased, especially out at the longer time ranges of days 4 and 5 of those track forecast areas have decreased as well. The storms haven't gotten any smaller. The hazard distribution of the storms hasn't really changed, but the cone, because of the way it's constructed, is shrinking and becoming a less useful tool in terms of hazard assessment, risk assessment from the cone itself. As I mentioned, it's not really designed for that. But when the cone was larger, it was a little easier to use for that purpose. And now that the cone has gotten smaller, it's really lost any ability to depict hazard risk, especially even at the shorter lead times, where the cone now is quite small and doesn't even adequately capture the watch warning areas for most storms. Here's again, remember, a hurricane is not a point. Hazards extend far away from the center. Here's an example from Irma, where you can see the track forecast cone, and you can see the size of Irma is basically covering most of central Cuba, and is expected to move over most of the Florida peninsula. And you can see here on the right side, the size of the tropical storm force wind field here in orange associated with Irma covered almost the entire state of Florida, portions of Georgia and South Carolina, whereas the cone was this very small area that was carved out along the west coast of Florida, where the center of Irma was forecast to go, but it didn't capture the fact that Irma wind field had basically doubled in size since the time it was in the Caribbean. Not just from the wind perspective, but also from storm surge and rainfall. You can see that the storm surge threat from Irma extended well outside the cone along much of the Florida East Coast and up to Georgia and South Carolina. The rainfall threat also extended well outside of the cone. So again, you can't use the cone to judge your risk from the various hazards. You have to look at other products to get that information. Now, we do have products that specifically are designed to communicate wind risk. These are wind speed probability products that provide the risk of tropical storm, 50 knot or 58 miles per hour, or hurricane force sustained winds at a specific location. And these probabilities account for the official NHC forecast, and then also account for the uncertainty in the track and the intensity and the size of the storm. Because remember, every forecast has errors. So some of we have to account for the fact that the official forecast could be too slow, too fast, too far left, too far right. We have uncertainty in forecasting the intensity and size of the storm. So this technique takes that into account. And makes this product really helpful in communicating the risk of wind impacts at a given location. So this is a product you can look at and say, okay, what's my risk of seeing tropical storm or hurricane force winds at my location? We also have information from the wind speed probabilities that help communicate information about when tropical storm force winds could begin at a given location. And these are the time of arrival graphics for tropical storm force winds. And these are really valuable because that arrival time of tropical storm force winds is such a key decision point or a key point in time for making preparations or evacuation decisions. Generally, most folks want to have everything done and wrapped up before those tropical storm force winds arrive at a given location because it's very difficult to make any preparations or other preparedness activities once those winds start. We have two different flavors of the graphic. We have one that provides the most likely time of arrival of tropical storm force winds, and then also an earliest reasonable arrival time of tropical storm force winds that accounts, again, for that uncertainty in the forecast of the storm. And this provides sort of a time range within which preparation should be complete. So for example, here you're looking at the most likely time of arrival of tropical storm force winds for Dorian. And you can see that in, say, here in the northwestern Bahamas, the most likely time of arrival of these sustained tropical storm force winds is during the day on Saturday. Here's an example of the timing uncertainty itself. This is the earliest reasonable time of arrival of those tropical storm force winds. This is the time at which there's only a 10% chance that the winds will start earlier than this time. So this is really the most conservative timing information. And what you can see that, say, here in South Florida for Hurricane Irma, the earliest reasonable arrival time of those sustained tropical storm force winds was Saturday around 8 a.m. or Saturday morning. Then we also have a most likely arrival time, which is the time at which it's an equal chance there'll be the winds will arrive either before or after that time. And you can see in Irma, in this particular example, the most likely time of arrival of sustained tropical storm force winds in South Florida was Saturday evening. So there was about a 12-hour time difference in the range of when those winds could arrive. So that's useful information depending on your risk profile, but it's also useful to communicate as a range. You could say that the most likely time the tropical storm force winds are going to arrive is Saturday evening, but they could arrive as soon as Saturday morning, and that can be a really useful message for preparedness. I talked about the key messages when we looked at the tropical cyclone discussion. These are really the sort of most important takeaways from each NHC forecast package. This is an example of the graphic of the key messages that we try to put out on our website and get out to social media. And they're really geared towards the general public, emergency managers, and the media, so that we're all providing consistent messaging on the threats and impacts from the storm. Again, trying to focus especially on the hazards and not get too caught up in the exact details of the track and the intensity and size forecast of the storm. But we'll start to point out, this is Irma, several days before it reached the Lesser Antilles. We're talking about how, Irma is expected to be a major hurricane when it moves closer to the Lesser Antilles early next week and could cause wind, storm surge, and rainfall impacts. But it's too early to specify when and where those hazards could occur. But people in those islands should monitor the progress of Irma through the weekend. And then another key message talking about either potential longer range impacts in the Bahamas and the continental United States, but just again to remind people, pay attention. The forecast is going to change. The information is going to evolve with time, and pay attention as we provide more as we go through the next several days. Now we get to the watch warning information. So just a real basic overview of what a hurricane watch and warning mean. A hurricane watch means that hurricane conditions are possible within the watch area, generally within 48 hours. A hurricane warning means that hurricane conditions are expected somewhere within the warning area, generally within 36 hours. Now, those lead times, that 36 and 48 hours, is tied to the anticipated arrival time of tropical storm force winds. We want to give people enough lead time to give them that 48 hours before those hazardous conditions begin, and 36 hours for the warning. So we try to issue the warning about 36 hours before we expect tropical storm force winds to start at a given location, so that people have at least 24 hours or 24 to 36 hours, including a full day of daylight preparation time to get ready for the storm's impacts before those tropical storm force winds arrive. Now, we do a lot of coordination because, again, we remember our international coordination with all the various countries in RA4 and elsewhere that, while we're making the forecast, each country is responsible for issuing their watches and warnings for their respective country or jurisdiction. So we'll make recommendations based on our forecast and using the timelines and sort of the criteria that we would use for issuing watches and warnings for the United States. But it's obviously up to each country to make their own watches and warnings decisions. We do a lot of coordination by phone with each country's meteorological services throughout the region. And again, I mentioned we try to issue watches, or we recommend watches be issued about 48 hours prior to when we think tropical storm force winds could begin, and issue warnings about 36 hours prior to the arrival of tropical storm force winds. The coordination process can be pretty complicated, especially when we have multiple countries involved, especially in the Lesser Antilles, when we have multiple islands that all sort of want to know what their neighbors are going to do before they might make a final decision. We're actually going to experiment this year, I hope, with sort of a video conferencing capability that will allow all of us to talk together at the same time, at least across portions of the Lesser Antilles, and try to make that coordination process more efficient so that we can all talk about the decisions that are going to be made at the same time, and we don't have to end up calling different countries back and forth as we find out more information. We always have at least 2 forecasters on duty during watch warning situations. And I did mention this potential tropical cyclone concept that allows us to issue watches and warnings before a system is formed. So for a system that has the potential to become a tropical storm or hurricane and affect land within 48 hours, we can go ahead and start advisories, get those warnings and watches out, get that hazard information out, and basically coordinate. We do the same coordination, just like if it were for an actual tropical storm or hurricane, and the watches and warnings mean the same thing, that there's that risk of tropical storm or hurricane conditions within that time frame for a given location. After the storm, we write what's called a tropical cyclone report that provides a complete summary of information for every Atlantic and Eastern North Pacific Basin tropical cyclone. They're available on the NHC website, mostly months after a storm is over, especially after a season like 2020. We just finished up the last tropical cyclone report, I think in late May or early June for last hurricane season. But this is where you're going to find the final summary of the storm. What was its final track, intensity, and size information? We go back and look at the final best track of the storm and take into account all the data that we have and the ability of looking back on it in hindsight and make decisions about how strong, what was the peak intensity, how did we smooth through the wiggles in the track. We'll also include meteorological data, wind and rain and pressure measurements and storm surge information in terms of observed data that were recorded from the various countries that the storm affected. Damage and casualty figures, what were the damages, what were the fatalities, and we'll also do a verification. How good were the forecasts? How good were the track and intensity forecasts from NHC and from the various models for that particular storm? So all that can be found in the tropical cyclone report. Speaking of fatalities, I want to talk about what causes fatalities. In the United States, at least, which is where we have the most complete data set, water accounts for about 90% of the direct deaths in tropical cyclones. Most of that occurs from storm surge, about half. 27% occurs from freshwater flooding due to rainfall, and another 12% occurs either in rough surf or rip current conditions or in marine incidents offshore. And about 10% of the fatalities occur either due to the direct wind forces of the storm itself or from tornadoes spawned by tropical cyclones. We've also noticed that we see now nearly as many deaths after and before the storm as actually during the storm, these so-called indirect fatalities that occur due to either accidents, carbon monoxide poisonings, heart attacks, medical issues, other traffic accidents. We're really losing almost as many people, if not more people, at least in the United States, to these indirect fatalities. And most of the indirect fatalities tend to affect the older part of the population. We see 8 times as many of the indirect fatalities for people over 60 as they are for people under the age of 21. Again, the focus is always on the hazards and the impacts. More impacts are occurring outside the cone. Don't focus too much on the category of the storm. That only tells you about the wind hazard. It doesn't tell you anything about the potential for storm surge or rainfall flooding. Especially rainfall can be almost entirely unrelated to the strength of the storm. It has much more to do with how fast the storm moves and how it interacts with topography and other weather features. Don't focus on the spaghetti models. There's a lot of model information out there that can be confusing or misinterpreted. That's really our job at the Hurricane Center, is to make sense of all that model guidance and create the most consistent, accurate forecast we can for everybody to use. And in terms of timelines, you're not always going to have 5 days notice. We're not always going to have Irma coming across the Atlantic basin and be able to watch it move across the Atlantic for 10 to 15 days. Some storms form very close to land, as we talked about. Some systems are not even tropical cyclones when they approach your area, but might be producing dangerous wind and rainfall. So you have to have that sort of timeline in your mind, that you're not always going to have that 5 days notice or even less than that to get ready for an event. We do a lot of other international collaboration that's not directly involved with the actual forecast and warning of the storm itself, but instead is really focused in off-season activities and training. We host and teach a 2-week workshop on tropical cyclones for international meteorologists that's sponsored by the WMO. We've had to do that in a sort of a virtual fashion the last couple of years. We hope to be able to resume doing that in person in 2022. We also would typically conduct a Caribbean hurricane awareness tour, where we bring the Hurricane Hunter aircraft and NHC staff to the Caribbean. That's typically done in April, and is a great opportunity to increase hurricane awareness in the region by meeting with emergency managers, government officials, the media, and the public. Unfortunately, because of COVID, we haven't been able to do the chat in 2020 or 2021. We hope to resume that in 2022 as well. And we are working on expanding the storm surge program into the Caribbean as we go forward. So that's all I've got. I'll be glad to take any questions or comments you might have. Thanks so much.
Thank you very much, Mr. Brennan. This is Valerie Diaz, the moderator. We do have one question beginning with Venezuela not being a country that is directly affected by hurricanes, however, is affected by increased rains. What methods are used for monitoring the rain in relation to the hurricane season?
Well, you're right. Venezuela is not a country that's generally experiencing a lot of tropical cyclone landfalls, but certainly could be affected by systems passing to the north. So what we'll do is we include rainfall information that comes from our partners at the Weather Prediction Center, that are the rainfall experts here in the United States, and they produce that information, and we include it in our advisory packages. We also produce our Tropical Analysis and Forecast branch produces forecast information across the Caribbean and portions of South America. Again, generally focused not as much on rainfall, but on wind and marine conditions. But we do have our tropical weather discussion that can highlight the potential for enhanced rainfall and flooding across our area of responsibility.
Thank you. Then we also have another question asking about what materials from your center are available in various languages.
We have a variety of material on hurricanes.gov, which is the NHC website. Most of it is in English. I'll try to follow up with Valerie and see what might be available in other languages. I would guess there is at least some Spanish content available, but I will follow up with that.
Thank you. Another question is there a mailing list to receive the alerts, watches, or warnings? We check the site constantly, but if you produce any good content beyond what is on the site, is there a way to receive this and be on a mailing list?
There is not an email list that's run by NHC that provides that type of information. There may be services available from private weather companies or other institutes or groups that might provide that service. There's also, if you're in the emergency management community, there is the availability of the Huravac software package that provides NHC products, both text and graphics, to emergency managers for their use. So that's something you could look into as well. I'd also encourage you to follow our social media feeds, NHC_Atlantic on Twitter. We do automatically post every advisory that comes out is automatically tweeted, and we provide a lot of other supplemental tweets that are made by forecasters that include graphical and other information when we have storm threatening land areas.
Thank you. And much along the same vein, there is a question related to what material is available for civil society in Spanish and in other languages. So what material is just available for the general public?
Sure. Again, hurricanes.gov has a variety of preparedness information. There's also preparedness information from elsewhere in the National Weather Service that's focused on tropical cyclone safety. There may be information available from various countries within the region and on their own websites. So I'd encourage you to check with your local meteorological service for any information that they might have that's more directly focused on your local community.
Thank you. One other question that has come up in the chat would, as you have said, not to focus on the category, as this is just specifically about the wind. The question would be, would minimal central pressure be a more accurate measure or determinant of the storm severity than the category?
Not really. The minimum pressure is just one sort of piece of information. It's really the gradient of the pressure that really drives the wind. So that would really only tell you about the wind hazard for the most part as well. And we actually can measure and forecast the wind itself. We actually don't forecast minimum pressure. So the wind hazard is really pretty well described already by, say, the Saffir-Simpson hurricane wind scale and the potential damage that those winds could do in a given location. It's just that the wind doesn't directly translate to the severity or the scope of the other hazards, especially storm surge and rain. So they really have to be treated independently of each other.
Thank you so much. Then we do have another question. Why are hurricanes named by boys and girls' names and following the Greek alphabet? What is the reasoning behind that?
Well, there's a lot of history to naming hurricanes. Back in the 1950s, there was basically an effort underway to name hurricanes to keep them to keep straight if you had multiple hurricanes ongoing at the same time, to differentiate one from the other. So originally it was phonetic or military alphabet, Alpha, Baker, Charlie, Delta was used to differentiate the storms from one another. And then eventually that transitioned to a list of all female names that was changed to alternate between male and female names in the late 1970s. And that name list now is actually governed by the RA4 Hurricane Committee. So there was just a change made at the Hurricane Committee meeting earlier this spring to get rid of the Greek alphabet as the overflow name list. So we have our name list that goes all the way through the letter W for each season. And we have 6 lists. We rotate through one list each year. So the list we're going to use here in 2021 is the list that was last used in 2015. But if we exhaust all the names on that list now, we actually have a supplemental name list that won't be the Greek alphabet, but will be regular names that we'll begin using, and that will start over with the letter A from a different list this season. So the Greek alphabet we decided to get rid of for several reasons. It was somewhat confusing. We couldn't easily retire storms off of the Greek alphabet list because you can't really replace a letter name with something else. It just would go away. And a lot of the Greek letters sounded very similar to each other in rapid succession in the alphabet: delta, or eta, theta, zeta, and it was sort of confusing to users. So we decided to move away from the Greek alphabet effective this year.
Thank you so much. We have another question. Many of our major operations within the Red Cross are activated by the heavy flooding after the storms. Is there a function of speed versus rain versus estimate of flooding levels that can be used to predict flooding levels due to this rain?
Well, in a very crude sense, the amount of rainfall you get is going to be directly proportional to the forward speed of the storm. So a slower moving storm is going to produce more rain at a given location than a fast moving storm. But it really does vary case by case. And then, of course, the flooding response to the rainfall depends on the sort of pre-existing conditions. Was the ground already saturated from previous rain, or has it been abnormally dry? That's going to result in a very different response of the river and creek system in a given location for the same amount of rain. The other thing that is important is the rainfall rate. If you have 5 inches of rain that falls over a 24-hour period, you're going to get a very different response in terms of flooding than you would from a 5 inches of rain that falls in 2 hours. So it's really very localized. It depends on topography. It depends on the pre-existing conditions of the waterways in a given area. So it's not something that can just be boiled down into a given formula. We really have to take every case as it comes and look at the rainfall potential for that given event, and then try to figure out what that's going to mean in terms of flooding impacts.
Thank you so much. And thank you for being able to take these questions as they come. Going back to the question about names, we would like to know about how the cyclones are named in the Pacific.
Sure. Well, in the Pacific, in the Eastern Pacific, in our area of responsibility, we have a similar naming system that we do in the Atlantic. We have a list of names for each season. We have 6 lists. They alternate male and female. And we start at A each year and we go through that list. And if we exhaust it, we would go to a supplemental list. So it's very similar in the Eastern Pacific to the Atlantic. In the Central Pacific, that's the Central Pacific Hurricane Center that's in Hawaii, has a list of Hawaiian names that they use for storms that form in the Central Pacific Basin. And they actually just have one big list and they just keep moving through it each year. So they just pick up where they stopped the year before. They don't have as many storms that form out there. And some years they actually don't have any storms that form at all. So they don't use a list for each season. They just have one big list of names that they work through. And in the Western Pacific, the typhoon naming is done by the Japanese Meteorological Agency. They're the RSMC for the Western Pacific in Tokyo. And they have a list of names that cover all the different countries and languages that reside in the Western Pacific, from Asian countries to the Micronesia to some American names as well. So they basically have a whole list of names there that they use in their basin. It's a little more complicated in the Western Pacific, though, because there are countries like the Philippines that have their own naming list. And so it can get a little complicated out there. In the Atlantic and the Eastern Pacific, it's very, very well run and regulated in terms of how we handle names and storms.
Okay, thank you so much. So we do still have a few more questions. The next question, I'm sorry, I'm trying to sort through what systems, and I believe this is something we will be discussing further at length, but what systems are in place for managing the pandemic when a hurricane comes?
Yeah, that's really a good question. That's sort of beyond our purview here at NHC. I can tell you about what we did last year. We had to adapt to COVID pandemic issues in our own facility and maintain social distancing. We spun up on remote operations. We did cohort staffing, so we only exposed people to a limited number of other staff. We did masks. We took all the preparations to keep our staff safe. And COVID is an evolving target in different locations and at different times. So the guidance that you're going to get from your local emergency managers or government officials about how to handle COVID and hurricanes may evolve as you go through the hurricane season. So it's really a very local problem that's sort of beyond the purview of what we do here at NHC.
Thank you again for being able to answer our questions. The next question, I'm also trying to make sure that I bring them to you in English instead of Spanish. Excuse me. I'm so sorry. I believe we also have some questions in the question and answer, if you are able to look at that.
Yeah, I'll take a look. Just one thing I did want to mention about,
go ahead.
Somebody had asked about Spanish language information, and I did want to point out that on the hurricanes.gov website, we do have some products that are translated into Spanish in real time, including the Atlantic Tropical Weather Outlook that's translated by the National Weather Service office in San Juan, Puerto Rico, and they also translate public advisories and key messages for systems that are affecting land, and especially in Spanish-speaking parts of the basin. So those are available basically in real time to serve the Spanish language community within our area of responsibility.
Thank you. And I would like to say many people have asked about receiving the information, and we will have this presentation and all of the information from the conference available on the website between this weekend and on Monday. Okay, so we in our country with Costa Rica have been working in forecast-based financing. How developed is this theme in our region, and is this something we should be considering when planning for hurricanes in the face of COVID-19?
Yeah, that's something I'm not familiar with, forecast-based financing. So our focus is on the meteorological forecasting, and that's it. So we don't get into things like financing or insurance or anything else in that regard. So I'm probably not the best person to try to answer that.
Hi, this is Emmanuel. Mike, I've already had an issue with the computer. There's another question from Steve McAndrew from the IFRC. He says, is there a speeding up of the intensity of storms from category 1 to 4 or 5? It appears like that was the case for Irma, which went up 4 grades overnight, and also Iota. It seems as if they are intensifying faster.
Yeah, that's a good question. I see Steve's question here. We do have cases of what we call rapid intensification, where a storm strengthens by at least 30 or 35 miles per hour within a 24-hour time range. And we have seen a lot of rapidly intensifying storms in the Atlantic in the last few years. Unfortunately, several of those have rapidly intensified just prior to reaching land. We haven't seen a real upward trend in RI overall in a long-term sense. It sort of takes very specific conditions have to come together for a storm to undergo that type of rapid strengthening, but we certainly saw it several times last year. And that's one of our biggest forecast challenges, because obviously the impacts are going to change if you go from a category 2 to a category 4 in a 24-hour period, and the forecast didn't reflect that. It's also challenging that even if we do forecast that type of strengthening, we know from social science and talking to users that people tend to focus on what the storm is at the moment, not even taking into account what the forecast intensity is supposed to be by the time the storm affects them. So even if the forecast was great, we still might not have people paying attention to the right types of information in those situations.
Thank you, Mike. There's another question from Juan Basso. He says, in recent years, we have had an intensification of hurricanes in a few hours. How much is it influencing the accuracy of the forecasts?
Well, that's again that type of rapid intensification that I mentioned, and that does affect our forecast accuracy. Those are some of the most challenging forecasts we make in terms of forecasting intensity change. We've gotten better at forecasting those types of rapid changes, but typically it's difficult to determine exactly when the rapid intensification is going to start and how long it's going to last. And while we have better forecast guidance to try to give us a forecast or information about how much intensification could occur, they really sometimes fail to capture what the atmosphere actually does. Like, we may make a forecast suggesting the system might strengthen 45 or 50 miles an hour, and it might strengthen 80 miles an hour. So we're able to anticipate the environment that favors rapid intensification in a lot of cases, but the details of the forecast sort of elude us still in many of those circumstances.
Mike, allow me just a second to check if we have more questions.
While we check more questions, this is Roger Alonso, IFRC. Yeah, I would like to, I think it's been placed in the chat, but we're going to have a specific session on finance-based forecasting, and we're going to go through, probably that will answer much better this question from the colleagues in Costa Rica. Also, I would like to ask, we have a question in the chat, what have you seen or have you observed an increase in terms of intensity or number of hurricanes due to climate change? Can we establish a pattern or a trend based on the impact of climate change on the last years?
Not directly. I think the more direct connection that can be made to tropical cyclones and climate change is that sea level is rising, which is exposing more areas to storm surge vulnerability. and warmer air holds more moisture, which has the potential to increase rainfall rates and flooding potential from tropical cyclones. So I think those we know are going on. In terms of differentiating hurricane intensity now versus years ago, we don't have a great record of hurricane intensity going back beyond maybe 40 or 50 years, even in the Atlantic basin, which has the best records of any basin across the globe. So it's hard to detect long-term trends in the database. And there's still a fair amount of uncertainty in analyzing hurricane intensity, even when we have a lot of data. So there may be some signal there, but it might be small compared to the uncertainty in the analysis or just other noise in the data records that we have. We know that from the current thinking is that in future climate scenarios, we may see the overall number of storms decrease, but we may see an increase in the very strongest storms, and increase in category, a proportion of the storms would be category 4 and 5 might increase. So for example, we'll have the same number of category 4 and 5 hurricanes as we do now, but we might see the overall number of tropical storms and hurricanes begin to decrease. So we might have fewer weaker systems, but the same number of strong systems in some future climate scenarios. But that's still an ongoing area of active research, and there's not a lot of certainty in any of those conclusions yet at this point.
We have a couple more questions. One says that, has it been observed an increase in intensity and frequency of hurricanes based on the impact of climate change?
Yeah, I think that's the question I just answered. So.
All right, I'm going to read another one here.
Yep.
So we can affirm that hurricanes are more frequent and intense now. Can that be attributed? Okay, that's the same. What is the best way in which journalists and media can use NOAA's watch alerts and contents?
Well, I think asking from the journalistic perspective, the first thing I think about is don't focus just on the category of the storm and small changes in the intensity as the storm strengthens and weakens. Focus on the hazards, the information associated with the hazards for especially flooding, rainfall flooding, storm surge, wind risk. Focus on those rather than sort of on the details of the storm itself. I think your readers and the general public will be much better served by providing hazard information rather than sort of getting focused on whether the system is a tropical storm or a hurricane or what category hurricane it is.
So I'm gonna do a quick translation from one in Spanish. It's an open question from the Q&A box. It says, good morning. Are you open to collaborations or projects with in regards to working about prevention?
Not sure what kind of prevention you're talking about. We're certainly not involved in storm modification or prevention in that regard. That's not something we're involved with. That's not something that's really considered in the scientific community at this point.
There's an open question again. It says, maybe you have answered this one. I'm sorry, I'm getting a lot of questions and I'm trying to read them all from the different boxes I have here. One says, why do cyclones occur around the equator?
Why do or don't they? They typically don't occur very close to the equator because we need a sufficient Coriolis force, which is a force imparted by the rotation of the Earth, and that's basically zero at the equator. That's why you don't typically see tropical cyclones very close to the equator, but at least 5 degrees north or south of the equator, you have to at least be in terms of latitude before you'll get a tropical cyclone to form. They tend to form in the tropics, though, because tropical cyclones get their energy source from warm ocean water, and that's where you typically have the warmest ocean water is at low latitudes.
Great, thank you so much, Mike. Now I'm giving the word to Ria again. Thank you.
Hi, so we just want to thank Mike for joining us today. I think it was a very informative session. Thank you so much for your time. We know it's invaluable. And we would like to thank you on behalf of the IFRC for taking the time to answer all of those questions. I know it was a lot, but I think our participants really, really appreciated it. So I'd like to call the session to a close. and wish you all a very good day. And I hope you enjoy the other sessions we have planned for you today. So stick around, take a look at the schedule. If you have any other questions, let us know in the chat. Bye, everyone.
Bye-bye.